Okay, this is question 4 in the 2020 Functions Tech Allowed SAC. We're looking at what happens to these quadratics that have been restricted, and we're looking at the number of intersections between themselves and their inverse. And I'm going to use my CAS to observe, sketch the inverse from analysis, sketch inverse. Okay, so I'm making A1 to start off with. So I'm going to have x plus 1 squared plus b, whatever b is. And if a is 1, I'm going from minus infinity to minus 1 is going to be my restriction, which is why we've got this here. Okay, so if I open up a bracket, inside put x plus 1, square it, and I'll start with the first, which is plus 4. But what I'm going to do is I'm going to put this restriction in where x is less than or equal to -1 and press XE, because when I then drag and drop all of this, including the restricted domain, it only draws the bit that's expected. And if I do analysis sketch and I do inverse, there's the inverse, and they obviously do not intersect. So when b equals 4, no intersection. Okay, so now I'm going to take this and I'm going to change my b to equaling 2, which is the second thing that it's asked me. And if I take this, drag and drop, and I drag and drop, so it's just been moved down 2 units because of the 4 has become 2. So if I now wish to analysis sketch inverse of the red one, XE draws it, analysis sketch inverse, not of the red one, but of the green one. There it is there. So as B changes and comes down, this is coming across. I think we're going to touch at that point there when B equals -1. Whoa, where'd my graph go? Okay, so what have we got? We've got this analysis sketch inverse. Beautiful. So B equals -1. So I'm guessing when B equals -1 that they will touch. And analysis sketch inverse, and it does in fact touch. Yep, beautiful. So B equals 2, no intersection, B equals -1, touch on endpoint. And I reckon when B equals -3, then it's going to move down further and it's going to move across further. So if I make that -3, and it does go down further, analysis sketch inverse, beautiful, there it is there, cuts once. It's only 2 marks. I've talked about all 4 points. Okay, and I can see that as B changes, the endpoint moves down here and the inverse's endpoint moves across here. Okay, now let's make A equal to -2. So I'm going to have x plus 2 squared plus b. Is that correct? Because I've got plus a. So it's going to be -2, so it's going to be minus a. It's going to be -2. And x is going to be less than or equal to 2. So if I take this, I'm now going to make that -2. And I'm going to make that +4. And we're going to make that +2 because that's -A. And when I press XE, I drag and drop. Well, it's up over there. And if I do analysis G, the inverse, I get that. So at V equals 4, no intersection. But I'm thinking that if I come down to, that's going to come across to, and when B equals 2, they should touch. If I make this 2, if I don't press XC, I shouldn't lose my graphs, and I didn't. I want the red one, move up to get the red one, then press XC, the red one. Hey, that's happened. B equals 2 touch. B equals -1, B equals -3. I think we will have a cut 1 intersection. So if I make that -1, I don't press XE, I won't lose my graphs. Beautiful. Analysis, sketch, inverse. I want the green one, so yep, XE, and we did have an intersection point. And then when I have that as -3, and I drag and drop, and then I do analysis, sketch, inverse. The blue one's flashing. If I go up, I'll get the pink one at the end. That's very good. Now press XE, and there it is, same. So when it was equal to +2, that's when we had the touching. So part C then says make B equal to 3 and change A. So that's going to be 3. And we might just clear all that up. Now I'm thinking that when A is equal to -3, that's when we're going to have our intersection that touches. Oh, didn't work. Oh, I didn't change that to 3. Much better. And then if I do analysis, sketch, inverse of the red one, so go down 1, there it is, and that's correct, that's what happened. So when A equaled -3, therefore touch. So if A equaled -4, that would have to change to +4. If I drag and drop, and then I do analysis, sketch, inverse of the, whoops, went too far, come back one, that one, press XE, and I zoom in there, we have definite cutting. So cut. So when A equaled -2, we should totally miss. Oh, start again. Analysis, clear all okay. Take this, drag and drop. And analysis, sketch, inverse, we totally miss. Beautiful. So I no intersection. So I've kept b equals to 3 and I've picked 3 different values of a. And now I can say that when a equals negative b or b equals negative a, the end points touch. When a is bigger than negative b, there's no intersection. When a is less than negative b, they cut, as my general hypothesis. And now when I go into section E, I need to have a look at all of these, and you'll notice that they are one apart. Where this is A and this is B. So that for all of these, for all of them, A plus B equals, A is negative 6, negative 1. Because A is negative 6 and B is minus 5. A is, so in this case here, A is 5 and B is 6. So A minus B is negative 1. And for all of them, so for all of these, so I've done this example. And if I take my square root, there it is down there, and I take the parabola and I zoom in on that intersection point, you will see that there are 3 intersection points. One there, one there, one there. So when A minus B equals negative 1, or you could say B minus A equals 1, or A plus 1 equals B, take your pick as to what. Therefore, 3 intersection points exist.